If a wire carrying a current is placed in a magnetic field, it will experience a force. This is called the motor effect. The field between the poles of the magnet and around the wire interact. The resulting field catapults the wire downwards. The force acting on the wire can be increased by using a larger current, using stronger magnets, using more turns of a wire. If the direction of the current is reversed, the wire moves upwards. Similarly, reversing the direction of the field causes the wire to move upwards. What would happen if both the current and field directions were reversed together? The wire moves downwards. There is a simple rule for predicting the direction in which the wire will move. 1. The first finger, second finger and thumb of the left hand are placed at right angles. 2. The first finger points in the direction of the field. 3. The second finger points in the direction of the current. 4. The thumb then points in the direction of the motion. The simple direct current DC motor. When the switch is closed, a current flows through the coil. The sides of the coil experience a force which causes the coil to rotate anti-clockwise. As the coil rotates, so do the commutator halves. These change contact from one brush to another as the coil passes the vertical position. This changeover of the commutator halves ensures that the coil continues to rotate in the same direction. If the current through the coil is increased, the sides of the coil experience larger forces. The coil rotates more quickly.